Now I'm going to show you some models that you can use for multiplication. There's a bunch of different types. So the first type of model we're going to look at is the repeated addition model. So this is just what you would do on a basic number line. And you're going to think about how many groups of the number do you have. That's what we're going to be drawing. So the first one says a baseball ticket costs $8. How much would 3 tickets cost? So you would start at 0. And the first ticket, you would go up to $8, right? So starting here, go up to $8. I'll put an arrow there. That's for the first ticket. And then you'd have another one. So that would take you up to $16. It's another $8. And then you have another ticket, and that's going to take you up to 24. It's going to be your final answer there. So when you look at this, you have to say to yourself, is that 3 groups of 8 or is that 8 groups of 3? Well, I see 3 8s. So to me, that's 3 groups of 8 if we do this by definition, which would be $24. Of course, we'll put a label on the answer since it's a word problem. So if a baseball ticket costs $8, how much would 3 cost? It's 3 groups of 8, which would be 24. So that's the way you would model that one based on the way that it's written. If a bird flies 20 feet per second, how far will it fly in 2 seconds? Okay, we'll start at the beginning. After 1 second, it's going to go 20 feet. That's after 1 second. And then it's going to go another 20 feet. And I guess that's for 1 second. I guess this is technically measuring feet, so let's put 20 feet there, and then let's put 20 feet there. We did 2 groups of that, 20 feet and 20 feet. So that would be 2 groups of 20, which would be 40 feet in this case. So the numbers are measuring feet, but it's 2 groups of 20. It's not 20 groups of 2. And who would want to draw 20 groups of 2 anyway? That would take forever. So just the way that it's worded, 2 seconds, you draw 20 feet for the first second, 20 feet for the next second. So based on that model right there is 2 groups of 20, not the other way around. All right, so let me show you an array model or an area model. Rectangular array or an area model, whichever way you want to look at it. This is a great way to introduce the concept of area. So you can, let's say an area rug measures 4 feet by 5 feet. What's the area? So you could draw a picture of this one, right? So you can use dots if you want. So we have like 4 dots here go in this direction, and then we have 5 dots go in this direction. So you can see this is like a 4 by 5 if you want to think of it that way. If we go across the top and then down the side, that would be a 4 by 5. Or you can flip it, where you have 5 up here at the top and you have 4 down the side, and that would be a 5 by 4. But you guys know that's still going to yield the same area. The area would still be 20, right? You can also model this with intersecting lines. So we have 5 lines going vertically, 4 lines going horizontally, and you just look at the dots where they intersect, and the number of dots is 20, right? Or you could draw it like, instead of with dots, you could draw it as actual like a little rectangle. So you have 5 columns and you have 4 rows. And so you could call that 4 by 5 or 5 by 4, whichever, but the area of the rug, I guess, would be 20 square feet total. That's how we label square feet, because you have 2 dimensions happening. And so I know we haven't gotten to any kind of area or anything like that, but it would be 20. The main idea, the main concept here is 20. There's 20 dots, there's 20 little squares if you add them up, 20 dots here, however you want to look at it. But that's called a rectangular array or an area model. And then there's the Cartesian product model, and we've already talked about the Cartesian product before. So if you will recall, A cross B, this is a set. It's a set of ordered pairs where the first part of the ordered pair is an element of set A, and the second part of the ordered pair is an element from set B. So if you go back, this is set builder notation. That little symbol means element. This is all like a recall from the previous chapter. So this is another way that we can define multiplication, and I think I mentioned that in the video where we first learned about this. So remember, n of A, that means the cardinal number, how many elements. So if the number of elements in set A is little a, and the number of elements in set B is little b, then A times B is just the number of elements in the Cartesian product. So this Cartesian product is a direct lead-in to a multiplication. So if we want to think about this kind of like a tree diagram, that's another way we can kind of show this Cartesian product. Mike is getting dressed for a job interview, and he has 3 pair of pants, he has 2 shirts, and he has 2 ties. How many mix and match outfits can he make? And let's assume that all the pants and shirts and ties all go together. So I have one set. I called it P1, P2, P3. That's his pants. Here's the second set, S, S1 and S2. That's his shirts. And then the third set is T. It's tie 1 and tie 2. So I'm just abbreviating to make it go easier. So the way that you read through this is you go, okay, so if I want to pick an outfit, if we start here, the first thing you do is you put on a pair of pants. So you have 3 choices, right? P1, P2, or P3. That's your first choice that you have to make. Once you've chosen a pair of pants, then you pick a shirt. So if you pick pants 1, you might pick shirt 1 or shirt 2 to go with it. Or if you pick P2, you can pick shirt 1 or shirt 2 to go with it. Or if you pick P3, you can pick either shirt to go with it. And then once you've chosen a shirt, then what you're going to do is you're going to pick a tie. So branching off of each shirt, if I pick shirt 1 going with pants 1, I can pick either tie 1 or tie 2. Or if I had chosen shirt 2, I could still pick tie 1 or tie 2. And then you just go down the list, filling in the T1s and the T2s. I'm almost out of room here. You can see that last one there. So then if you kind of read through the tree, you can see that the outfits are basically, these are going to be sets of triples, right? So the first outfit would be P1, S1, T1. That would take care of that outfit. P1, S1, T1, or P1, S1, T2. That would be the second outfit. Or P1, S2, T1. Or, and that's this one, or P1, S2, T2. That's that one. Or, what if you didn't pick pants 1? What if we pick pants 2? So, P2, S1, T1. P2, S1, T2. Sorry, I'm supposed to mark them off as I go. Anyway, at this point, can we just go like this, y'all? Can we just go, etc.? And you would read through the rest of the tree. So how many total outfits would you have? Well, you just count this last set of leaves on this big tree. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outfits. But this is the long way to do this, right? That we're supposed to relate this to multiplication somehow, right? Well, it goes back to that fundamental counting principle that we talked about. So it's like a sequence of choices. You have 3 pair of pants, you have 2 shirts, you have 2 ties. If you multiply that together, you get 12. And that's a whole lot faster, so much faster. Please do it this way. Don't draw the gigantic picture every single time. But if you think of these as like, and now I understand that these are not ordered pairs, these would be ordered triples, right? Where you're pulling something from the set of pants, something from the set of shirts, something from the set of ties. This is a Cartesian product, it's just triples. So the number of objects in each set, in this case 3, 2, and 2, if you just multiply them together, or you look at how many are in the product, how many elements are in the product, if we wrote out all of these outfits, there would be 12. But the quickest way to do it is just to relate this to multiplication and multiply. So that's another type of model that we can use for multiplication.